Okay, we'll look at a very simple thing to calculate with vectors called the dot product. However, it does seem to cause confusion occasionally. It's useful for many reasons. I can't think of a direct meaning of what the dot product is. However, dot product is an easy calculation that's useful for a couple different reasons. So let's look at what dot product is. I'll first make a note of what you can do with vectors. We used scalar multiplication on vectors. So just a quick example of that would be if you multiply a vector by the scalar 2, so I can multiply a vector 2 times 3 comma 7, you get a new vector 6 comma 14. So you can multiply a vector by a number very easily, or a scalar. We also had vector addition or subtraction. And vector addition, if you take 3, 7 plus negative 2, 5, you get a new vector that is 1 comma 12. You simply add the components. So subtraction, you would distribute the negative to the second vector and then add the components, or subtract the second set of components from the first set of components. Okay, so very simple there. What I really want to point out is we do not multiply vectors. Okay? The reason I say that is because dot product looks much like multiplication. Here's what dot product looks like. Let's take 3, 7, the vector 3, 7, dot negative 2, 5. This is a dot product. So you read this as the vector 3, 7 dot the vector negative 2, 5. It's not multiplication. And the way that dot product is defined is it's going to be the sum of the horizontal components multiplied, which of course is negative 6, and the vertical components multiplied. 7 times 5 is 35. Okay? So it's a sum of two products, right? You multiply the horizontals together, get negative 6, multiply the verticals together, get 35, and then you add those together and you end up with 29. So dot product results in a number, not a vector. Like a scalar multiplication always results in a vector, vector addition and subtraction always result in a vector. But the dot product always results in a number. So you have to realize that the dot, when it's in the context between two vectors, means dot product. Okay, so that's the key here. Dot product is written as a dot, which can be confused with multiplication. So you have to know that in the context of a dot between two vectors, you're dealing with dot product. So, this is where it can get confusing. What if I write 3 dot 2, 1? Well, this is a scalar dot a vector, so this is not a dot product. This is actually scalar multiplication, and you would get 6, 3. Okay? So just notice the difference. A dot can be written in either context, but when it's with a scalar, it's multiplication. When it's between two vectors, it's the dot product.